Well, welcome back to math class. This time for math, we're going to review a little bit of the quadrants we talked about yesterday. The directions here say to describe the possible location or locations of the point X, Y. You do not need to write these directions down, but what I would like for you to write is this. I would like for you to write X is going to be greater than 0. And y is going to be greater than 0. Then underneath those two directions, I'm going to ask you to make kind of a small coordinate plane. This is our y-axis. This is our x-axis. We'll label that. And I want you to think about if I told you your ordered pair, x, y, that the x is going to be larger than 0, and the y is going to be larger than 0, where do you think your point would land? On the x-axis, on the y-axis, or in quadrant 1, 2, 3, or 4? All right, let's see if you guessed correctly. The correct answer is quadrant 1. So we're going to write here quadrant 1. Now let's think about y. If I told you x has to be greater than 0, well, when we plot a point, we always start here at the origin. If I'm going greater than 0, I'm going to the positive number side, which would be to the right. If y is greater than 0, that means I'm going to be going in the positive direction. So I'm going to land in quadrant 1. Well, let's see if you can solve this one. What if I told you x this time is less than 0? Write this down. And y is less than 0. Make your coordinate plane and circle in your notes where you think your point is going to end up. All right, we know that when we graph a point, x and y, we start at the origin. The directions that you were given is that x is going to be less than 0, so I'm going to move in the negative direction. This would be negative numbers. Y is going to be less than 0. Well, less than 0 would be I'm going down in the negative direction. So we would land right here, which is called quadrant. Do you remember? You are correct. It is quadrant 3. All right, let me give you one more. What if I just told you that x is going to be greater than 0? I'm not going to tell you anything about y, so I'm going to ask you to go ahead and make a coordinate plane, a small one, and show me, circle in your notes where you think we can plot this point. This is x, this is y. We know that this is 0, 0, x and y. So y can be positive or negative. Well, if I'm going to be on the x-axis and I'm moving in the positive direction, that means I'm going to be going this way. So now let's see my y. I can either go positive or negative because I didn't specify. So that means we could have landed in either one of these quadrants. 1 and what's this one? You are right, quadrant 4. All right, so for this next section, I just want you to pay attention, listen carefully, and just follow along. So I have here a coordinate plane that I've made. I put my positive numbers on my x-axis and my negative, my positive numbers and my negative numbers on my y-axis. I'm going to label my axis. This is x and this is y. So you will notice I've listed here some ordered pairs. 3, 2, 5, 2, 1/2, and negative 2 1/2. 2.5, and negative 2.5. We're going to actually take these ordered pairs and we're going to plot the points, connect the dots, and actually make a polygon. So let's notice we're going to do 3, 2. So I'm going to go over to 3. There's my 3, up 2. There's my first dot. My next dot says over 5, up 2. Okay. Then the next one says I'm going to go over to 1/2. Let's see. I noticed we had this yesterday. If this is 1, where's a half going to be? It's going to be right here in between the 0 and the 1. So we're going to go halfway, and we're going to go down to the negative 2, and we have to go an extra half. The next one we have is we're going to go over to the 2.5. Here's 2, here's 3. Halfway would be right there. We're going to start here at 2.5. We have to go down 2.5. We're going to connect the dots, and you will notice I've made a polygon. The polygon shape I've made is actually a shape we've talked about before. This is a parallelogram. It's also known as a quadrilateral. So sometimes we're going to give you points like this, and I want you to be able to graph them on your coordinate plane and close the shape up by connecting the dots. So the other skill I'd like to talk to you about, besides drawing polygons on our coordinate plane, is finding the distance between points. Finding the distance between points means something like this. So if I had a point that would be right here, and my other point would be right here, and I would connect them, and I would say, well, what's the distance between those 2 points? Well, distance is a measurement. So one of the things we could do is we could notice that this point right here, if I look at what the ordered pair is, I'm going to go here, and it's going to go backwards. 1, 2, 3, 4, 5, 6. So it went negative 6, and then I went down 1, 2, 3, 4. So this ordered pair for this dot is negative 6, negative 4. If I find this point, I'm going over 1, 2, 3, and then it looks like I'm going to go down 1, 2, 3, 4. So I have my ordered pair. If I want to know the distance, now I could just look at my line here, and I could count my boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I could tell you that the distance between these 2 points would be what we would call 9 units. Now, some of you are actually smart enough to not have to draw this and count. Some of you are going to notice that, well, they both have the same y coordinate, but if you notice, their x coordinate is different. From the y-axis right here over, I went 6 units. And from the y-axis to the right, I went 3 units. What is the absolute value of negative 6? Remember, absolute value. Well, the absolute value of negative 6 is 6. And what's the absolute value of 3? Well, that's 3. And if you add those 2 numbers together, you will also get the same answer. All right, so here's another example. I've got this giant coordinate plane here. You can see it's pretty big. I've plotted 2 points, and I've told you where they are located. This one is in quadrant 1. This one is quadrant 2. What is the distance from this point to this point? What is the distance? Some of you are actually looking and are going to sit here and count the boxes, and you can count all the way to here and get the answer. Some of you are going to use your absolute value and notice, well, from this blue y-axis all the way to this is an absolute value of 7. And from this y-axis all the way over to the negative 8, remember the y-axis is 0. What's the absolute value? How far is negative 8 away from 0? 8. If I add 8 plus 7, what do I get? 8 plus 7 is 15. If I have a hard time seeing that, then I can count all of these little boxes. And I could have gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I will still get the same answer of 15 units. Now, if you notice, the 2 points that I've plotted are in 2 different quadrants. What do you think would happen if I plotted this? So, these are the points. This one is at positive 3, negative 4. And my other point is going over to positive 8, negative 4. There's my 2 points. What's the distance in between them? Now, if you noticed up here, I was able to add the 2 numbers, but that's because 1 point was in one quadrant and 1 point was in the other quadrant. Down here, both of my points are in quadrant 4, so I can't really add anything. The best bet for me to do is either A, count from here to here, 1, 2, 3, 4, 5, or if I look carefully, my y is the same, negative 4, negative 4. So if I look at the x, if I'm going from 8 to 3 and I subtract 8 minus 3, I will get the answer of 5 units. Now let's think about this. There's 2 ways to find the distance. I could have counted 1, 2, 3, 4, 5, or I could have looked at the x. The 2 numbers are 8 and 3. The distance from 8 to 3 is 5. This is how we're going to find distance between our points on a coordinate plane. All right, so before we finish up here, I'm going to give you 2 challenge problems that I'm going to see if you can solve for me, and I'm not going to give you a coordinate plane. Now, if you want to draw it, you can. But what I'd like for you to do is if I give you the point 2, 7 and 2, 9, can you tell me the distance between those 2 points? I want you to see if you can solve it. And then I also want you to tell me the distance between points negative 3, negative 8, and positive 6, negative 8. How many units apart would these 2 dots be? And how many units apart would these dots be? So go ahead and pause your video if you need to and see if you can solve these 2 problems for me. So if I don't have a coordinate plane drawn out, I probably would do something like this to give me a visual. This is X, this is Y. If I'm going to go over 2 up 7, it's going to be about right here, I'm going to guess. And then if I go over 2 up 9, it's going to be up even higher. So I'm having a distance from here to here. Well, obviously, because my X coordinate is both 2, I'm looking at 9 and 7. So I would say 9 minus 7. My answer is 2 units. Let's see how you guys did with this one. Once again, I probably would give myself a little visual. An X and a Y. Negative 3, negative 8. Negative 3 is going to be somewhere about here. Negative 8 is going to be about down here. Ooh, this one's going to be positive 6 and negative 8. So I'm looking at something that's going to cross into 2 quadrants. So I'm probably going to use absolute value. If this is negative 3, negative 8, that means from here to here, the absolute value is 3. This is over 6. So from here to here was 6. So I would probably add 3 plus 6, and I would get an answer of 9 units. All right. Well, I would like for you to go ahead. Your teacher's probably going to give you some sample problems for you guys to practice. And then I will see you guys tomorrow.